you've started the engine after that without checking, and that's why you need a new crankshaft. So that came in very handy. So then we'd move on to, we'd document the failure. So, okay, what's happened? A lot of the time the crew would try and help and collect everything, which is all right, but I guess you still need to scout around. It's surprising how far things can fly in an accident, and how many things just completely disappear. Collect the components, inspect the components. So I take a little USB microscope, laptop, and we would do the best we could with, I guess, brain, eyes, and computer. And then anything we had identified as being interesting, we would send back to the lab in Germany. If that meant that we were sending a whole crankshaft back, having to chop that up, that's what happened. We had a crankshaft failure. We requested it come back, and we ended up having two pieces, each with about 1,000 kilos, air freighted from an island that didn't have an airport, so they had to put it on a ferry, take it to the bigger island, put it in a cargo plane which was just on the limit of being able to take off, get it to Germany, about 25,000 euro just to get the crankshaft back to the lab. I haven't got too much longer. I guess here's some examples of what I would typically turn up and see. So here we've had a connecting rod failure. Here, that's the connecting rod shaft and small end. It's typically bolted with 4 bolts onto the crankshaft. So there'll be a bearing lower housing and a bearing upper housing. In this case, the counterweight, which should be here, has come off. And I guess I haven't investigated this myself. I'm not sure what the cause is. But looking at the pictures, either one of the bolts, one or more of the bolts of the connecting rod failed, weren't done up properly, or a similar occurrence on the counterweight. I believe this engine failed very shortly after a service, I think 40 something hours. So I guess my money would be on someone forgot to do up the bolt. I guess there's no description. This is purely just to show you a lot of crap lying in the sun. You'd have to get in there and get it out. That one actually looks like there's not too much oil. I've been in ankle deep, well, calf deep oil, trying to scoop up any metal I could. And then I would sit on the floor puzzling through, well, crankcase, okay, don't care, or cylinder liner, oh, interesting. Oh, a bit of a bolt, very interesting. The crew must have thought it was insane. They hear an expert's coming, and then there's a guy sitting on the floor picking through metal pieces. Some other examples. You've got a turbocharger that's had a minor mishap. That's part of the turbocharger. You've got a counterweight sitting out here, and you can see that everything's covered in oil. I guess when an engine like this goes bang, you've probably got a couple of minutes before emergency shuts down. So a couple of minutes at 500 RPM is enough to spray oil all over the room, typically throw out some more engine components as something's whacking around. Here you can see there's a connecting rod
red for each table.
Well, lodged itself into the crankcase.
They're coming.
Now
Okay, I'm sorry.
right here, I guess I can't give exact examples of failures. And I won't mention where this happened, but I can, I guess, describe what happened. So we've got our connecting rod. It's a 3-piece connecting rod, lower, upper, with shaft and the head. Now, a certain cruise line were replacing the small end bushes here. It sits in
Do you want to say anything about the line?
And the instructions state that it should be pressed out. Now, obviously, you need to have a press, and that's going to take you a fair bit of time. They thought that they could use an angle grinder to speed up the process.
Yes.
Yeah, fair enough, go for it. What ended up happening was they cut a little too deep and went into the connecting rod. Now obviously you can imagine these are highly stressed machines. Within a few hundred hours there was a fatigue crack that had initiated and propagated through the head, opened up and wiped out the engine. So I guess a colleague of mine that investigated this was talking to the crew, and they said, oh yes, we recently replaced all the small end bushes. And he said, okay, how did you do that? Oh, we do it with an angle grinder. Ooh. Okay, and then he was looking at the fracture surface and there was a bit of mechanical damage where the crack had initiated from, and he said, okay, how many other engines have you, all of them? And he said, okay, well, straight to the captain. He said, this is what we have seen, this is what we've been told. Knowing this, we can't work in the engine room anymore. And that was it. You guys pack up all that, send it back to the lab, and that's what the outcome was. Next issue, again, connecting rod. We have fretting here. This is the bearing housing, so this was the lower one. An engine in Spain. From the fretting, there was a crack initiated. It went through the bearing housing. Connecting rod came off the crankshaft, shot itself through the side of the engine. In this case, they managed to get away with repairing the crank case. They metal stitched a big plate back in, and they managed to polish the crankshaft pin. So they were lucky. That was a big accident, but a minor outcome, if you can say that. I guess another Spanish occurrence. This was one of our licensees. They had machined the connecting rods themselves, and I guess you'll see this is from down here. When they machined the lower cap of the connecting rod, for whatever reason, they had machined the flat here and part of the radius and stopped. Then they came in from the other side and machined around. Now I guess it's not common practice to do a radius over two I guess, cuts. If done properly, I can only assume it should work. However, they didn't match up. In the middle of this radius, there was a ginormous, I guess, ridge. And you can imagine a nice big stress concentrator in the middle of a radius. We had a beautiful fatigue crack through there. I think this was 238 hours, so it lasted a little bit. Again, off the crank, through the side of the engine. There was a nice big I-beam, probably a metre back, that it put a decent sized dint in. This ship was getting ready for sea trials, and they were quite worried that they weren't going to be able to sail, and we said, well, you're going to need a new engine. We said, well, what about the other engine? There were two engines in here. We pulled off the covers, and every one of the connecting rods was exactly the same. So everything got replaced. It wasn't a matter of remachining it. We were quite concerned that if a crack had initiated, we may or may not see that with magnetic particle. There's a good chance you would, but if it's a fine crack, we were worried that we may miss it, and it was something, I guess, too risky to worry about. So everything was replaced.
Are these man-made?
Well, they're not there.
A licensee.
So your quality control was up the chute?
Yeah, so one of our licensees, they had, I guess, well, obviously the license to build our engine, and obviously they hadn't seen, or they didn't understand what they'd done was wrong. And then obviously after I pointed out there's a big ridge in the middle there, and that's not on the drawing. Even not speaking Spanish, they understood. I guess this is even more concerning. Again, connecting rod, I guess these are probably the most common failures. This part is the top section. That's the ball hole for the studs to keep the big end together. This was a licensee in Asia somewhere. They had bought the forgings from a supplier that we had blacklisted. And you can see here, this is actually a magnetic particle inspection with black powder. There's forging defects.
Good.
There were a couple of failures. There had to be a recall. So I guess these are things that you wouldn't expect to happen, I guess, in Germany, but obviously we try and make sure all the licensees have exactly the same quality system as we do, but sometimes things get through. Again, another connecting rod. It may look a little funny, but this is, I guess, a typical Danish design. It's an angled connecting rod. You can see here that essentially that's the lower cap, that's the upper cap which is connected to the shaft. We have a serrated parting line, and the studs go through there and through there. Now, because the studs don't go all the way through the connecting rod, you have a blind hole. And we found that when they were machining the thread, the cutter was so blunt, it wasn't cutting, it was just kind of deforming the material. You can see here we had multiple crack initiation sites through the thread, and the thing went bang.
How big's that range?
That is, I think, a 2738. So that's probably 1.5 metres long. So there to there. So it's not something, even that is still, if that's coming out of the engine, you're not happy about it. Change topics. This is a piston pin. We had a rather unfortunate incident where some of our material, we used to specify a very pure material for our piston pins because we knew the implications of having a material defect or inclusion in there. Piston pins are a funny, I guess, component. You can't really say it's going to be safe after a certain number of cycles. Because the piston pin rotates, you can't be sure it's being loaded the same every time. So you could have one of these fail after 5 cycles. You could have one of these fail after 20,000 hours, 100,000 hours. So we had an issue where we already knew which ones were going to fail, and unfortunately at that time they weren't listed in which cylinder they were installed, and sometimes not even in which engine. So we had a list of which were affected, but we couldn't track them. So most of them we knew it was from this point in time to this point in time. We sent out NDT technicians to check every piston pin. We found that this got most of them. However, we also saw some pictures of how they were doing it. And if you know, I guess, I'll go to the next picture because it helps explain it. That's where the piston pin sits. If you can imagine, you pull the piston pin out, but you leave it sitting just on the edge. You're doing your ultrasonic testing, bang, 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 and then you push it back in. Obviously, there's a few centimetres at the back that haven't been tested. And we found that one of the people testing was doing that. We obviously have a 100% surface check, and we found that they weren't pushing it out the back and doing that area. So we got most of the piston pins that were affected, but we found that there was always a couple of stragglers that followed, and I had a running spreadsheet that, yes, 351, found you, tick. This is, I guess, a piston. You can see there's a crack through here. This was caused by a cracked or failed piston pin. So once the piston pin pretty much breaks, you start to lose, I guess, a nice oil film. Things start to overheat. You can see the seizure damage, and you start, I guess, stressing components that shouldn't be stressed.
Is piston pin the same as gudgeon pin?
Yes.
Yeah, okay.
Yep. Here we have a valve. Now, depending on what engine size, they may range from so big to so big, and up to probably 15 kilos, the big boy. Here you can see there's a burn through. I guess it was always important for us. Diesels, especially the heavy fuel engines, produce a lot of soot, a lot of combustion residue, and if that sits on the valve, we don't get a proper seal. So you can have two problems. If you get 98% of it sealing and 2% not sealing, then your combustion gases shoot through the 2%, and it's like a hot knife through butter. it will just slice straight through. And then once you've got a small bit, it keeps growing and growing and growing. And so that's, I guess, a good example there. If, for whatever reason, you start to get cracks in the hard facing, these would typically go straight through, and then because of the, I guess, the stress of when the valve closes, you're essentially pulling the shaft at the middle up, and it starts flexing the outer regions. The crack would change and run around here, and you'd ultimately end up with a mushroom. So there'd be a shaft with a small mushroom.
Thank you.
Sorry, can I just interrupt you for an important question? What would you like to drink?
Another beer, please. Oh, thank you. Thanks, David. Now, this is broken away. Obviously, you don't want things breaking away in the combustion chamber. We used to call this the big wear package, because when you drop something inside the combustion chamber, it would typically rattle around. So you're talking about a piston crown that's damaged, you're talking about a cylinder liner, maybe a fire ring. You typically take out a couple of the valves, you destroy the top surface of the cylinder head, injector, the air starting valve. This would then break up into smaller pieces, make its way back out the exhaust, down, and typically take out your turbocharger. So big wear package was probably €250,000. So it's not something you want, but it was, I guess, a common occurrence, and the question is always, well, why? And then you'd start looking at, okay, valve clearance, was there cracks in there for a reason, is the material defective, and go through the typical process. This is a piston crown. It's a bit difficult to see, but you can, here there are some indentations. That's the typical type of condition we would find them in. There's a lot of build-up, and here are the, I guess, the scallops for the valve, here, here, and here. And yeah, a lot of the time these would still run. You probably wouldn't know. Obviously you know when you lose a valve, but I guess this just comes down to the operator decided not to change the piston crown when they had a damage. Now we've seen things like hammers, screwdrivers left in the combustion chamber that will rattle around until something's destroyed.
That can be a faulty fuel injector as well.
Yep. Now, last slide. This is a bearing. I guess what is interesting, these holes here should be round. Now you can see that, well, there's a couple that are round, there's a couple that aren't so round. So, bearing seizures, we used to have systems on the engines. We'd have an oil mist detector. So when something cracked and there was an oil mist inside the crankcase, we would typically detect that, and the alarm would go off, and you could save the engine before it goes bang. We also had splash oil, which is a little cup, and any oil that sprays around the engine, it would measure the temperature. So we're typically in bearing seizures, we would see all the splash oil's gone off on cylinder 5. Now the normal procedure would be to stop the engine because the alarm comes up, take off the cover, inspect it. That never happens. That never happens. It's restart, oh, alarm. Restart, oh, alarm. Restart, bang. Oh, we've got a problem. We had one instance where a bearing like this had actually cracked completely through the middle and split into two halves. One half worked its way out to the side and started cutting a nice big groove in the fillet radius of the crankshaft. Okay, they realised that they had a bearing seizure, alarms were going off. They inspected the pin, it had to be polished, checked the hardness, everything was alright. They didn't notice the nice big cut in the fillet radius. I think about 1,000 hours later, it was a beautiful fatigue crack that had propagated from the groove all the way through the crankshaft, and I ended up in England at a third-party laboratory trying to explain to some loss adjusters that their customer hadn't repaired their own engine properly and it wasn't a materials fault from the factory. And when they realised that there had been an accident beforehand, they were very upset, let's say. So that's the end. Thank you for listening. If there's any questions.
Can we do something different?
Yep.
Can we just talk amongst ourselves while he eats his tea and
Yeah, good idea.
and beer, and then we'll have the questions immediately afterwards. So plan your questions, guys. The best, most complicated question that you can't answer, I'll reward you.
Thank you.
Just